This is Learning Assessment Problem 611. The problem states that two initially uncharged capacitors are connected together in series to some circuit, and after a period of time we see the conditions indicated in the diagram. Let's call this second capacitor C2. Presumably upon connecting to the circuit, a current will flow charging these two capacitors. At this particular observation time, we have 6 volts across the 12 microfarad capacitor, and we are asked to determine the value of the capacitance C1. So we'll have a voltage V1 appearing across that capacitor and a voltage V2 shown as 6 volts across the C2 capacitor. Each capacitor will take on a charge. We have Q1 Q2 for the second capacitor, and recall that we have the condition that the capacitors are charged by the same current, and thus the current the charge being a function of the current in an integral fashion, we'll have that each capacitor will take on the same amount of charge because the same current is flowing in each of those for the same period of time. So the principle will be that Q1 is equal to Q2. And finally, we'll proceed with the calculation here. Now we'll proceed to analyze the circuit. We have the C capacitance is defined by the Q divided by V relationship, and we're saying that in the prescribed conditions for the problem that the charges on the two capacitors are the same. So we have that Q2 is equal to C2 V2, and this will be 12 microfarads times 6 volts, which is equal to 72 microcoulombs. And that's also equal to Q1. Now, observing by KVL, we have that the voltage on capacitor 1 V1 is equal to the circuit applied voltage 24 volts minus VC2, which is equal to 24 volts minus 6 volts, which is equal to 18 volts. So now we can calculate the capacitance C1 value as the Q1, which is 72 microcoulombs, divided by the voltage 18 volts, and this is equal to 4 microfarads.